All right, everyone. Today we've been asked to take a look at a single line diagram for a two inverter, two battery system. So that is 25 kilowatts with 40 kilowatt hours of energy storage. And so today's video is going to be pretty brief. We're going to just go over what this design looks like, and we're going to add a little bit of comments if we see anything that we might want to edit, and then we're able to then get that signature for this installer. So let's take a look. Let's introduce the system a little bit right here. You see it's going to be a 12.88 kilowatt DC system, where we're going to be using the load output of 25 kilowatts from both inverters to feed all of the loads. And so, yeah, again, 40 kilowatt hours for the energy storage system. They are using REC panels with some Tigo optimizers and rapid shutdowns. And so they're going to be having, again, two inverters with two batteries with 4 strings of 5 modules and then 2 strings of 4 modules. All right, so let's take a look at the grid side over here just to make sure that everything is done correctly. All right, so we see the 200 amp breaker feeding a accumulation panel, a grid combiner panel over here that has 2 separate 100 amp double pole breakers. I'm seeing that it connects to a non-fused AC disconnect, and so this is a knife blade disconnect. Seeing that going from the grid to have another disconnect right here that goes into the grid terminals. Does it? Yes, it does. Perfect. On inverter A, let's follow the second line, okay, to another AC disconnect that goes to the grid side on inverter B. Perfect. Okay, so by the way, leader and follower here in this scenario, so we're going to be configuring it when we commission the system. And so one comment I would have here would be this right here, these two fuse disconnects. That is going to be an entirely dependent on the AHJ, the authority having jurisdiction. So you're going to want to double check with them whether you need this or not. And I mentioned this right here, since you have this 100 amp double pole breaker as the OCPD, the overcurrent protection device, to the inverter right here. And also, by the way, each inverter does come with a grid disconnect switch as well for the grid connections. And so you're going to have protection here, protection at the inverter. And so again, if your AHJ requires it, absolutely you must install these. But if it does not require it, then you are good to go. Also, you see right here, if this right here is a 200 amp double pole breaker, this is a single means of disconnect to the entire system. So we are good on that end. Now I'm looking up here and I see the Savant Power Director. This is the brains of the system. And so I do see that it goes from the internet to the Power Director, but then I see that it is connecting from the director to each inverter, and that is not how we're going to want to make this connection. So what would I do? I recommend would be to install a network switch right here. And basically you are feeding the internet with an Ethernet line, you are feeding the switch. And then from the switch, you are going to feed the director. And then from the switch, you're going to feed inverter 1. And from the switch, you're going to feed inverter 2. That way, all these 3 devices are connected to the switch, and the switch is connected to the network itself. Okay, and then the other thing that you are going to want to make sure is that you do have the parallel cable between the inverters A and B. So the leader and the follower, they must have a communications cable so that they are in parallel. That was another point definitely wanted to make. So you're not going to connect from the director to each inverter. And let's see, let's take a look. On the solar side of things, I mean, they are doing strings, 2 strings of 5. What is the voltage on the modules? Let's take a look down below. Right here. All right, they got some calculations for us. So the Vmax that they're gonna see per module, 69.21 volts. Our maximum right here that they divided it is 450, so divided by 69.2 is 6.5 maximum number of modules in series, which means 6 is the maximum number in series, and 5 is definitely less than 6, so we are good on that end. This is a check I would typically have to do. I'm glad that they showed this in this single line diagram itself. I also see that they are using the Cloud Connect CCA for Tigo that is connected to a single pole 15 amp breaker on the load side. Now let's take a look at the load side real quick. So both load sides are feeding 100 amp breakers right here in this combiner panel, and then they are going to be using a 125 double pole breaker to feed all the rest of the loads in the home. Actually, one more thing that this customer wanted to possibly do is to add a means of bypassing the inverters if they ever need maintenance. And so what would that look like? Basically, that would look like this right here. We would recommend they bypass ATS, automatic transfer switch, or a manual transfer switch over here, where you are transferring basically from the inverter loads, feeding all of your home, to having the grid feed all of your home for that time for maintenance. And we do have a lot of these diagrams available, so don't hesitate to reach out with any questions. All right, so those are some of the comments that I have right there. And any other questions that you might see, feel free to point out in the comments below. Thank you for your time. Hope you learned something today.